So for this video, we'll be going over the topic of momentum and its relationships, and then changing momentum. So as you know, momentum, the equation for momentum, P equals mass times velocity. That's something we know. And then another equation we have for momentum is the change of momentum. So change in momentum equals the derivative of force with respect to t. So derivative of f dt. So as we know, we've looked at in the past the relationships between like other things such as acceleration, velocity, displacement. So one thing we know that about the derivative of something, say it's the derivative of f. Of course you can solve the derivative in other ways, but one way you can do it is just by finding the area under the curve between two intervals, like in an interval between two x values. So that's something that you'll have to do often if they ask, like, what's the change in momentum? Because we have an interval here, all we need to do is, if it's between time 0 and 2, we would just, let's look at the graph. If here's 0 and here's 2, we just find this area, this cumulative area under that curve. So now we're going to go on to the practice problem. So we have a graph, and for number 27, the question is, the graph above shows a variable force that acts on an object as it moves along a straight line as a function of time t. What is the change in momentum of the object from t2 seconds to t4 seconds? So, just like we worked on here, they gave us the graph of force with respect to time. So, to find the change in momentum, all we have to do is find the area below the curve from 2 to 4. So now we have the graph right here. Here, I'll just draw it right here so people can see it better. 1, 2, 3, 4. And this is force in newtons, and this is time in seconds. So 1, 2, 3, 4. It just goes like that. So at t2 seconds, the force in newtons is 2. And at t4 seconds, the force is 4 newtons. So all we have to do is add the area under these curves, and we get, this is 2 times 2, right? So that's 4. And then this is a triangle, isosceles triangle, 2 by 2, 2 times 2 over 2, which is 2. So all we have to do is add that area. 2 plus 4 equals 6. And that is the change in momentum. And one thing we have to remember is that for the momentum, momentum equals mass times velocity. So the units for momentum is going to be kg divided by kg times meters over seconds. So our final answer is going to be 6 kilogram meters per second. And so this was a fairly easy problem, and especially with this equation, the delta P, or change in momentum equation. So one final thing, just to reiterate, is just remember, if you're finding the integral of something and you have a graph of it, all you have to do is find the area under the curve between the interval that is listed to get the change, to get the answer. And that's what we did here.